Hello, Algebra 2. Today we're going to review some two-way table probabilities, and then we're going to continue and define what it is to be a mutually exclusive event and how to compute the probabilities of compound events as we move forward. So first, let's warm up with this example. So we have some data on some juice bottles. So the boss or one of the quality control engineers of whatever company, I don't know where it's at, we'll talk about that in a minute, has subjected a few bottles of juice to some tests. We don't know what these tests are. Maybe they're pH tests to determine if they're too acidic. Maybe they're tests to make sure there's no flies in the juice bottles, or human thumbs, or anything like that, right? It's another Friends reference. There's an episode of Friends where Phoebe finds a thumb in her can of sodas. I was thinking about that that would be definitely a fail, the test, right? Okay. So, the first thing we want to do is compute or find the joint and the marginal probabilities, find their frequencies. So the first thing to doing that is, I think, just finding the totals for each row and column. So these are pretty small numbers, and you don't even really need a calculator. So I'm going to say there's 19 morning tests, 14 in the afternoon, 17 there. And now I can just add all these up and get the grand total down there, which was how many bottles? Is it 50 bottles of juice that were tested overall? Okay. So then over here, I'm going to go and add the column up to get how many passed overall. So it's going to be 24 and 11 is 35. And I could add these up, or I could just make use of the table. And in this assignment / others, you should start playing with that idea. 35 plus what's 50? 15. If you add them up, you'll get the same thing. But that kind of reasoning, I think, was even on this weekend's assignment, especially with that strep throat problem, which was the most important one by far. So anyway, those aren't the joint and marginal frequencies. Frequency is kind of like another term for chance or percent, exactly. So we need to turn each one into a percentage. So how many out of the total 50 were in the morning and passed? That'd be 14 out of 50. Would you guys get as a percentage? 0.2 what? 8? Okay, I'm going to trust you guys on this one. So then 5 out of 50, that's pretty easy. That's just 10%, isn't it? It's 0.1. Maybe I'll put 0.10 to be clear. 10 out of 50 is also pretty easy. That's just double 5 out of 50, so 20%. 11 out of 50 is just slightly more. I'm going to guess it's about 2% more, am I right? Okay, 4 then is 2% less than 10 approximately, so about 8, am I right? And this will be 2% more. Of course, you probably want to use your calculator for those. So these guys all add up to, that's 50 and 20 is 70. So I know this has got to be what then? If that's 70, this has got to be 30 in order to get my 100%. You can add these up likewise. Looks like we have 38% there, 28% there, and I could just subtract from 1 if I wanted to get the last one, or add this up, kind of up to you. 34 it looks like. Now it's possible that these don't quite add up to exactly 1, and in fact, do these actually add up to 1? I don't think they do. They're close, isn't that like 1.02 or something? What is it?
It's 1.
Is it 1 exactly? Oh, we lucked out. There could be some slight errors because of rounding, right? Like we were truncating or cutting them off by rounding. So it might not add up to perfectly 1, but the idea is if you didn't round, it would add up to 1. Okay, so that's number 1. I'm just going to leave those in the table. Trying to write those over here would be a nightmare. So I don't know if the other examples that you were provided in the video on Thursday described how to write a sentence. You probably need to go back and add a couple of these. So, how do you describe the marginal distributions in a sentence? There's actually 2 marginal distributions, one for each margin. We've got the margin over here. That's its own distribution that adds up to 100%. We've also got this marginal distribution along the bottom of the margin that also adds up to 100%. Writing out a marginal distribution is really important to understanding all kinds of parts of data analysis. So pretty important, okay? So let's do this one first. So I'm going to say 38% of the juice bottles were tested in the morning. then finish out the rest of the distribution. 28% were tested in the afternoon. And 34% in the evening. So sometimes the marginal distribution doesn't tell you a whole lot. I think this is one of those cases. More bottles were tested in the morning than any other time. To me, that kind of makes sense because probably when people get to work at first, they're a little bit more productive. In the middle of the day, there were a little bit less that were tested. Maybe that would make sense if you think about a siesta. If this was like a factory in Spain or Greece or somewhere that has kind of a middle of the day slowdown. But there's not a huge amount of difference in those numbers, right? The point of a marginal distribution, though, is for you to start thinking about the sizes of how one quantity relates to another. Very important. So now I need another sentence. So you're going to have two sentences on each one of those problems I requested a description on. The other one's going to describe the other marginal distribution, which is going to be, I'm not going to write it down this time, but 70% of the bottles tested passed, while only 30% of the bottles failed. You can see I put the while only there to clarify. I think that's a lot more informational than the other marginal distribution. Why? If you're the owner of this bottling factory, are you worried or are you not worried? I'd be pretty worried if 30% of my bottles are failing whatever test I'm subjecting them to, whether it's just a pH test or whether it's some kind of more concerning test like, are there flies in those bottles? Something's wrong with my production line. Maybe there's oil leaking in, maybe there's an opportunity for the flies to get into the pop bottles at some point, juice bottles. I'm pretty worried. So that marginal distribution really says, better go and check things out. Something is awry, okay? So definitely write out that as well. Okay, next question. What's the probability a bottle was inspected in the afternoon given it failed that inspection? So anytime like this, you guys should be really writing these as symbols, and I'll be looking for that on quizzes and tests, okay? That's designed to help you, and you can't do more advanced problems without it, really, or it makes them a lot harder. So you should have said the probability and tried to describe your event. So we wanted the probability a bottle was inspected in the afternoon, given that it failed. So first you should say the condition, the given, is that it failed the inspection. This is a conditional probability. Given it failed, what are we interested in the chances of finding? If it was sampled off the production line in the afternoon. Of course, is this all the pop that this factory is producing? No, we're looking at 50 bottles out of, I don't know, thousands probably, right? So, is the sample space all 50, or has it been shrunken in this example? It's been shrunken. They have to be a failed bottle to satisfy that condition. So how many of those are there? It's only 15. That's the shrunken sample space. The probability it came from the afternoon is 14. 4. Does that make sense? So what is that percentage?
26.
It's not 66%, no way.
26.6.
26, okay. So there's a 26% chance there. Last question. On which shift is a bottle most likely to pass inspection? I'm guessing this is a question that the manager or the owner of the factory would ask to figure out which employees maybe are not doing such a good job, are not being as rigorous with their testing than others. That might be a reason you'd ask this. Good. Break some heads in there in that shift. You know what I mean? Yell at them or something. I don't know. Probably won't work, but figure out something to do with those guys. So, what probabilities should we be investigating on this one? What do you guys think? What's the condition? I think we want to look at the probability of something given something else. What's the condition? Given that it passes. I think there's different ways to answer this question, really. On which shift is a bottle most likely to pass inspection? So let's say given, I think we could look at given the morning, and then on this one, given that it's from the afternoon, and then this one, let's look at given that it's from the evening. And each time we want to look at the probability of what? That it passed. On this question, you might be able to get the right answer by flipping those around as well and looking at the probability that it came from the morning given that it passed. And likewise for the other three, I think you can probably answer the question either way. But let's just do it this way since that's what we decided on. So the sample space now is shrunk from 50 to just the morning tests. There were 19 of those. This one is shrunken from the 50 to the afternoon tests. There were 14 of those, and there were 17 evening tests. So the passing ones in the morning, there were 14. Passing ones in the afternoon, 10. Passing ones in the evening, there were 11. Now those numbers are all, as fractions, really difficult to interpret what's better, what's larger, and so forth. So we want to turn them into a decimal. So can you guys help me? 73? I'll just say 0.73 or 73%. 71%. 64%. So what does these three numbers, what do they tell you about number 4? Technically, most likely to pass inspection when? In the morning. I'm thinking that probably makes sense because people maybe are not quite as with it in the morning. They might let kind of more things pass. Their eyes might be stuck shut in the pH test they're running. It has like different grades of blue and red. They don't read it right quite as often, so they kind of just let more bottles go. There could be all kinds of reasons. I'm speculating. My speculations really can't be supported by the data, but I'm trying to read into what's going on. Okay, so answer is morning. So there's an example, again, of marginal distribution and two-day table calculations.